till my kids come home and start like stomping and
Yeah.
screaming.
All right. Well, I guess this is the last session of the day. We're going to wrap it up early. So, Jason, if you'll give us the lowdown on RBD Journal blueprint, we'll go nuts.
Yeah, sure. I think it was about a month ago I posted to the mailing list a rough draft design for a generic journal. The initial use case of this journal would be to support RBD mirroring across data centers. So I'm just gonna try to go through some of the high-level goals and design decisions that that I talked about in that email thread. Talk about where we stand and how this would integrate with RBD. So at the highest level, the goal of this generic journal is to be generic, and so it could be used by not only librd, but then in the future maybe by MDS or other clients as they need to. So it's going to be based on the Librados API. It's not going to, unlike the current journaler code, it's not going to interface directly with the objector. And also different from the current journaling code, it's whereas the current journaling code uses the striper internally, so it'll as you write data to the journal, it'll stripe it across multiple objects as you keep adding more and more entries. This design is going to splay full journal entries across n number of objects. So if you say that you have a given object set or journal object set, within that set you could have n number of journal objects that define that set. And just to keep it simple, let's say the display width is 2. So basically what that means is that whenever a client uses the journal API to submit a new entry, it's going to round robin, the entries back and forth between the two journal objects until what point, and at some point those journal objects will get full. So you can configure a soft maximum size for those journal objects. And the reason I call it a soft maximum is because it's possible that the sizes will go over, that the individual object sizes can go over that size, or they could also be under that size, because when you submit your append operation to add new entries to the journal, the first operation in your op would be a guard assert. It's a new class method, OSD class method, and that basically just does a quick check to say, well, is the current journal size larger than the prescribed maximum soft size? And if it is, it can return an error code so that operation can get retried on a new non-full journal. And once a journal is detected that it's full, it'll basically result in the entire active set, the current active set, being closed. So that this was a change from the original design as talked about in the mailing list, and the rationale was it was going to be too hard to track the potential of which objects are still open and which for writing, which ones are open still for reading based on different clients and where their current reading positions are. Because in the crazy case, you could have every odd, display width of 2, every odd writes to the journal is the full max size, and every even write is like 1 byte or something like that. So suddenly all your odd journal entries are, you're now at object 901, but your even object is still on object number 0 because it hasn't been filled up yet. And trying to have to then iterate through hundreds of possible files to see where you truly are during replay operations didn't seem that efficient or smart. So it's a sacrifice potentially that you could close an active set while some of the objects aren't fully up to the soft max size. But assuming on average with the round robin everything stays pretty consistent with the size, then you shouldn't notice any truly hot objects where one's at 1 megabyte and the other one's at the full object size or something like that. And certainly in terms of code implementation, it seemed like a good trade-off to make, because then I only had to track what's the minimum object set that we know is still on disk, and what's the current active set that we know all objects are being written to, instead of each individual object for a given round robin offset. one of the things that when I started implementing, one of the things that Sage asked me to think about was making sure that it could properly buffer up all the requests. So that in the current draft code I have right now, it can buffer up the requests based on a flush age, where you say, well, I want you every n number of seconds, I want you to then actually send the data off to the journal on the OSDs to commit it to disk, or after n number of bytes, or after n number of actual like journal entries, you can also have it flush out to disk. And then it automatically flushes out to disk when it knows that you've now exceeded the object size as it's tracking in memory. So it knows, well, this object should now be full, so let me actually dump out all the data I have right now so I can fill up this one object. Another goal of the of this new journaling library is that it can support multiple readers concurrently. And so for the RBD mirroring use case, the goal here being is that you could have one data center. It's the active consumer and writer of the image. So you have some VM that's actively writing to that image, and all those writes are being now journaled out. And then you can have 2 other data centers, 3 other data centers, doesn't matter. They're all registered consumers of that journal. And those other consumers are watching the journal and the journal objects, and they're trying to pick up and try to keep up with real time of where the journal is, in the original active data center. So now each client can have separate, basically commit positions of where they're valid to, where they've successfully saved all their data to their local OSDs. And another feature is that this would also support multiple writers potentially. And an RBD use case example for that would be, let's say you have a VM that's got 5 different RBD disks. You can have all 5 of those RBD images journal to the same journal, so that now you have a point in time consistency across all your disks for that given VM. Let's see. I put in the journal, in the Etherpad, I put in a bunch of details about, the high level design, what the journal header looks like, what data it keeps, what the journal objects, the individual journal objects look like, what each individual journal entry looks like. Don't necessarily think I will go through it here unless anyone has any specific questions. But before I move on to interaction and interfacing, how this is going to interface with librd, does anyone have any questions about the journal?
So earlier in the day, I think the first session with the Ceph, we talked a little bit about like coalescing pending data deletions from the MDS into something like this journal structure. John, if you're still around, do you have any questions about that?
I think I saw his sign off right before the session started.
Okay. All right, I'll have to ask him later then.
Yes, want to keep it so it's actually useful besides someone besides RBD would be nice. And I took some of the design principles from the current MDS journal in terms of how there's the tools that can help the current MDS journal recover from corruption. I kind of blended some of those concepts into this new design so that, if you've got a partial corruption of your journal object, it can still scan out and find the remaining valid entries within the journal and let you know, just this one specific entry is corrupt or missing or whatever.
Cool.
Obviously, librd would need its own tooling set because it would have different journal entries that you could potentially do things with, but at a high level, it's concept-wise all the same. All right, so moving on. Oh, go ahead.
Just mentioning it might make sense to have some generic tools or infrastructure, not tools directly, but that would support checking the journal and trying to repair some of it. Or
yeah, so you can definitely have like a generic tool that lets you know that this specific entry is invalid, or do you want to yank it or whatever. So you can have a generic tool like that, but in terms so the Ceph journal repair definitely gets into well, let me go apply inode, maps that I recovered from the journal, and that's obviously a little more specific towards the MDS lifestyle.
Yeah. Just making that infrastructure more generic, not having a same command line tool, but just making it able to be used by both.
Yeah.
An RBD repair tool and a Ceph repair tool makes a lot of sense.
Yeah.
Good.
All right, so moving on. So integrating this with librd, so the user side of RBD, it's gonna basically result in a new RBD feature code. This will be starting with Infernalis. You can dynamically enable and disable certain feature codes as long as they don't muck with the structure of the actual image as it's laid out on disk. So for instance, you can turn off exclusive locking and turn it on, object map, things like this. So this would be another one of those dynamic feature bits that you could turn on or turn off. And specifically, when we talk about journaling, I think there's journaling and then there's mirroring. So I think at the end of the day, there's going to be two different sets of operations that you do. Like I want to enable journaling on this guy, and also, hey, I'm going to mirror this guy, and here are the other data centers that you should expect to mirror from it once you turn on that journaling flag and the mirroring flag or feature bit or whatever, however that's going to be implemented. So in terms of all mutable IO operations, so your writes or discards, all those things would be recorded to the journal. If you have the RBD cache enabled, it can basically, as the operation comes into librd, it'll submit it to the journal. And then it can basically immediately submit it back to the cache. It would just need to make sure it delays the write back side of the cache until it knows that the journal has successfully written itself or committed itself to disk. If you have the cache disabled, then your IO would need to wait until it actually knows that it's been journaled first, and then it can submit it over to the OSDs to. Once you get to a point where all the OSD is telling you that now your write operation, your discard operation is now safely committed to the OSD, then the librd will go back and tell the journaling API, hey, that operation XYZ, it's now safe, so we know it's safe, and here's I can move my commit point up to, at this point, the oldest uncommitted change or unsafe change that's currently in the journal or recorded by the journal. Unsafe op from the OSD and your actual RBD image manipulation point of view. So besides IO operations, all the necessary maintenance operations on an RBD image that can perturb the metadata about the image, those would also need to be journaled, so that in the case of RBD mirroring, those changes could be replicated across to a different data center. So if you resize, create a snapshot, remove a snapshot, all those things would just need to be recorded so that they could get played back in an alternate site. And if you have journaling enabled on your RBD image, when you open an image in read-write mode for the first time, it'll have to go through replay mode. If you cleanly closed your image, there won't be anything to replay, because in theory, your commit pointer should be exactly at the current head pointer of the image. But if it's not, it'll replay all the journal commands back through librd from the last commit position up to the most recent entry. In case you have cache on, I guess it wouldn't necessarily need to wait. You could basically just submit it and forget about it. But if you don't have the cache on, then it would probably need to synchronously wait for all those things to properly flush out before it returns control back to the user.
Yeah, I think it would probably be the same as the regular IO path with journaling enabled, right?
Yeah, I mean, I'm just saying that it would actually have to track the completion. It actually have to track the completions of the writes coming back. If you don't have the cache enabled, versus in the other case, it's somebody else, Cube or whatever, tracking the completions.
What you're saying, right?
Any other questions? That's basically what I had to present.
It's also worth noting, I don't remember if you mentioned this explicitly, but this is all depending on the RBD exclusive lock feature. So that only one RBD client will be modifying the journal at a given time, and only one will be like replaying at a given time. So there's no corruption.
That is true. Good point. Anything else? Crickets?
Nothing
Other
else?
questions? I think I'm just eager to see the code.
Yeah, I provided a link to the tracker. There's code up in GitHub in the work in progress branch.
Okay.
Draft code for the journaler client side API. All right.
Awesome. Well, I guess that makes that easy.
Short day.
A lot shorter than it was gonna be.